Hi, I'm Justin.
And I'm Michael.
And this is our podcast where we discuss what we find interesting about the intersection of Web3 and digital security as we know it.
Between us, we have years of experience securing digital products and infrastructure, which has led us to be constantly curious about what's next.
Which is what this podcast is about, sharing our journey as we update our mental models for security in the next internet. Hello, and welcome back to Not Your Crypto Podcast. Apologies for the minor hiatus. We are publishing a week off after we should have. But we're back, and we're here with another episode. I'm your host, Justin, with my co-host, Michael. Michael, how are you this week?
I'm doing good. I'm looking out the window at the snow, beautiful snow coming down, and it's making me feel happy right now. So
it is. I swear, I put up my Christmas decorations this week, and when there's a light dusting of snow on the ground, it just feels all that more warm and cozy and fuzzy. I'm a big fan of Christmas. If anyone knows me, you'll know that. And with that being said, what are we talking about this week? Okay, so this week we're talking about another hack. This is going to be a technical analysis, effectively. It's a technical analysis of a hack that occurred by my math 3 years ago in August of 2021. And it's a hack that occurred on another blockchain, actually. And why are we talking about this particular one? Hacks seem to be a dime a dozen these days in Web 2 and Web 3. Let's not get any mistaken. Well, this one I feel like is going to basically has stimulated some thoughts in both Michael and myself around security in Web 3, around the age-old conversation around centralization versus decentralization, which we talk about a lot. The way it happened and what manifested as a result of what the attacker did. It's basically prompted some interesting thoughts from myself and from Michael. So this week we're talking about we're talking about a hack on the Poly network. Not to be confused with Polymarket, which we discussed in our last episode.
Yes.
Please be very clear. Polymarket, separate discussion. Polymarket is a prediction market, almost effectively a gambling website that uses blockchain under the hood. Poly network is a separate blockchain, wholly contained in of itself. Give us a brief overview of what Poly network does, Michael.
Oh, sure.
Okay, I can do it. If you're
I
not
can try.
Okay,
We'll do it together.
Okay, cool.
Okay, so Poly network is, I think, what it describes itself as is like a cross-chain network.
Yeah.
So we've had a few other episodes where we talk about bridges, right? Or maybe only one. I don't know.
I think there's one, A Bridge Too Far.
Yeah. I just remember the title of it.
I'm very proud of these titles, by the way. We love our episode titles, everybody. Michael comes up with most of them. So if they do put a smile on your face, please let us know. We'll continue to do
that. So a bridge is a way to have a way to transfer assets from one blockchain, one like layer one, I guess, blockchain to another layer one blockchain and get them talking to each other, essentially.
Basically, yeah.
So a cross-chain network is, I think, in my mind, a similar kind of thing in that it helps to coordinate communication. It helps to coordinate between different blockchains, between different L1s. In my mind, where it kind of is a bit different than just a straight up like bridge, or what you would call like a classic bridge, is that it's not only about just like transferring kind of an asset or a token from one chain to another, but it's about transferring communication. It's a bit more two-way, transferring communication from one chain to another. So for example, so like we're talking about like the Bitcoin network, we're just talking about, Bitcoins, right? Like a token and moving that token from one place and getting a token on another blockchain. Yeah. If we're talking about something like Ethereum, or any of the other chains that now have smart contract functionality, you could have smart contracts on one blockchain, and you can have a smart contract on another blockchain, and you might want those smart contracts to talk to each other.
Yeah.
So a smart contract is just code, bunch of functions that you give input and that give you back output.
Yeah.
And so a cross-chain network kind of sits, you can think of it as sitting in between.
Yeah.
And let's say smart contract A on blockchain A wants to talk to smart contract B on blockchain B. The cross-chain network would facilitate communication between that, taking the output from A and giving it to the input of B and vice versa.
Exactly.
Is
And that's
that
how I understood it. And then I was like, okay, what potentially could be a use case for it? And I think I hit upon a decent analogy with gaming. So follow me here as I talk it out loud for the first time. So effectively, one of the things that blockchains like to talk about with the USPs is having an asset in a game that can go into another game. So
mm,
you have Animal Crossing on Solana, and then you have a game Michael designed that on Solana as well, and you may want to interchange an asset between the two of them. Where I see a cross-chain network like Poly Network come into play is, imagine if I have Animal Crossing on Solana, but I also have a copy of it for some strange reason, or I have another game on Ethereum, Animal Crossing version. So imagine if you have a PS5 version of your Animal Crossing and a Nintendo Switch version of Animal Crossing, and you want to move the data from your PS5 to your Nintendo
you
Switch.
want to move your Fortnite skin from
Exactly,
yeah.
from one to the other because you've sold your Switch, whatever's happened, or whatever, or you've sold your PS5 or whatever. That's where you'd have a cross-chain network coming in. So basically, it's about facilitating communication between two different fundamental sets of infrastructure, and that is, and it's only specific to smart contracts, right? This isn't. This is almost another analogy that came to my mind because I initially, when I came across this, I was like, why would it be different to a decentralized exchange? And like you said, decentralized exchanges and bridges that support those things, that support those entities, are specifically about exchanging assets. They're not about calling code from one blockchain on another to be able to execute some function that lives there. So that's why you have something like Poly Network.
Mm-hmm.
Problem is, as with all things, much to the chagrin of Michael,
Oh.
blockchain world is highly financialized.
Mm.
So there was a lot of money floating around on Poly Network, and where the money is, come the grifters, come the innovators, come the opportunists. And so, unfortunately for Poly Network, the opportunists came, and this enabled. They basically discovered some vulnerabilities that we'll go into in a little bit that allowed them to effectively try and steal $600 million. The reason I say try is foreboding for what actually happened, because they did get the $600 million. They just gave it back. But that's a story that we'll discuss later. So, yes, Poly Network effectively exists to enable the communication between two fundamentally different smart contract
Mm-hmm.
blockchains.
And I think you can think about cross-chain networks maybe as
Mm-hmm.
like a superset of bridge. Like
Mm-hmm.
you can also exchange assets, like
Mm-hmm.
flat
You
assets,
can.
as to my understanding, on
Yes, you can.
these kinds of things you would consider a cross-chain network. So it's almost like a superset. It's like,
Mm-hmm.
like bridge functionality, but kind of elevated to the level of this smart contract stuff.
Yes, exactly.
And
Uh,
then, well, who? No, you can go ahead.
no. That was it. I was just going to go
Okay.
on to. So why do we care, kind of thing? Unless you were going to say something.
Do we want to talk a little bit about like the structure, the
Mm-hmm.
technical structure of the polychain
Yes, we
network?
do
Because you mentioned
actually.
that there was like a lot of kind of value within it, and so like why is that value there, kind of thing?
Yeah. So why is that value there? Yeah, we can go into that. So effectively, the way Poly Network was effectively under the hood, you have a separate blockchain. You have a series of smart contracts that are deployed on each of the chains that interact with it. So Poly Network will have a chain on Ethereum, it'll have a chain on Solana, it'll have a chain on Avalanche. Is Avalanche a nail one? Anyway, it will basically have a chain of a contract, because obviously that's how you get to interact with Poly Network in the first place. If you're on a Solana, you use the contract that they've deployed to Solana to go and call another chain. It then has a set of wallets that have tokens, because obviously people who participate in the blockchain, this is wallets and tokens are first class citizens of blockchains, because that's what enables the decentralized nature of them. So you then have a set of wallets that are effectively storing all your Sol, which is the token of Solana, or your ETH, which is the token of Ethereum, and so on and so on. These wallets have a lot of assets, and when those assets go up in real dollar terms, basically you're sitting on a vault full of money. So they have wallets that are governed, access to which is governed by a series of smart contracts. And then you have the blockchain that actually interacts, the actual Poly Network blockchain that interacts with all the other blockchains. So that's
Mm-hmm.
kind of what it is under the hood. Have I oversimplified? Is there anything I've missed, Michael?
No, I don't think so. I don't think so. But I think like to me, like this construction isn't necessarily obvious.
No. Mm-hmm.
Like it's like you could construct a cross-chain network
Mm-hmm.
in a different way.
Mm-hmm.
And it's probably something we'll talk about later, but in
Yeah.
a more like, if you were just like, okay, I'm going to build something that has this cross-chain functionality and that
Mm-hmm.
plugs smart contract A into smart contract B on blockchain A on blockchain B.
Mm-hmm.
The actually simplest way to do it is probably to like just have an application, like a server,
Yeah.
like a DApp basically,
Yeah.
that, you know, calls the thing,
Mm-hmm.
gets the output, and then calls the thing on the other side or whatever, right?
Basically, and
Um,
just syncs up in between, right? It just
yeah,
syncs up the
exactly. It syncs in between.
transactions.
So like, you know, you have a centralized
Mm-hmm.
service
Mm-hmm.
that does that.
Yeah.
But that's not how Polychain is constructed. So like the
Poly network.
Poly network. Oh gosh, thank you. You're catching me already.
No worries.
I've said Polychain so many times, I'm sure.
It's
Like
only
in my
what's
head,
fun.
it's like the same word.
Yeah, I mean,
It's design is to also is to look at that
mm-hmm.
whole thing and say, well, okay, if I were to build like an application to do this, like a
Mm-hmm.
centralized application to do this, what if I built it distributed instead?
Yeah.
Like how would that work? Could I
Mm-hmm.
build a distributed application that does this?
Mm-hmm.
And you can, because it's all just code,
Yeah.
right? It's all just code.
Yeah.
So like that's why it has kind of its own blockchain sort of thing that
Mm-hmm.
runs
Yeah.
the code for it. And then manages the wallets on every side of the thing on each
Yeah.
blockchain that it's integrated with.
Yeah.
So yeah, it's interesting from that perspective, right? It's like
It's
we
very
talk
interesting.
about the ethos of all this, right?
Mm-hmm.
Which is like, if a thing can be decentralized, it is going to be decentralized, sort of, right? And so it's like, okay, this thing that very naturally feels like I'm going to have a centralized thing, actually, we're going to build it in a decentralized way
Decentralized way.
because it's all just code.
Yeah, it's all code, and it's interesting when you start to think this through to completion, because you're like, okay, so you are now going to house assets as a chain for every chain that you integrate. So the more chains you integrate, the more assets you hold,
Mm-hmm.
the more risk effectively you're going to be sitting on.
Mm.
So that's the first thing that comes to my mind with this decision to decentralize everything, because now you're just you're not exponentially, but you're just scale. As you scale, the more wallets you have, the more money you have. And it's an interesting one, because then it comes back to, okay, what is with code being law, the more code you write, the more complicated the thing becomes, the more risk you inherently are hosting as a platform as well. So now you've got this interplay between, I'm increasing risk in real dollar terms, I'm also increasing risk in execution terms as well. And again, we'll see how that comes into play in attack such as this. So those,
and like you said, the market as well also increases risk under your feet as it goes through a bull run or whatever.
Yeah, as we go through these bull and bear cycles that crypto are just native to crypto. Well, not native to crypto, but a part of a characteristic of crypto markets. So these are interesting decisions made by the Poly network developers and creators. But again, when you're a decentralized maximalist, this makes sense. Code must be law. What this has now done to my brain, though, again, foreshadowing for some of the thoughts I have when we do our conclusive thoughts at the end, is it's ironic, because the whole thing is supposed to build trust with its trustlessness. But I feel like there comes to a point when you go to such an extreme that you undermine trust.
Okay.
From the outside. We'll get to that anyway. All right, so August 2021, $610 million goes walkies from the Poly network blockchain. Everyone sees it. As you all know, this is blockchain,
you can't not see it, right?
Everyone sees this happen. So how did this happen? Okay, in my summary, from what I understand what happened, you can keep me honest as per usual. An attacker effectively exploited two very specific sets of vulnerabilities. Well, no, sorry, they exploited two smart contracts in order for this to happen. Two underlying smart contracts that support the Poly network blockchain, and more importantly, the process of talking from one blockchain to another. So buckle up. This is obviously going to get technical. We're going to try and keep it as simplified as possible. But long story short, if I am on Ethereum and I want to execute in Solana, I have to call a particular smart contract on the Poly network to that basically will transmit my request for a particular function or a particular piece of code on Ethereum or Solana or vice versa. And Poly network is in charge of transmitting that request and then and then transmitting the reply back to the original user. I am doing this via a smart contract on the Poly network, and the Poly network was set up with a bunch of smart contracts that support this, but one of them in particular, had access to control who can move money out of those many wallets that it has access to. And it needs access to these wallets because it needs tokens to interact with the blockchain. That's how blockchains are supported. An attacker realized that although that contract that could have that owned access or governed access to the wallets was very much locked down and secured in terms of the methods that could be called on that contract, the pieces of code that could be run on that contract. So not anyone could just walk up and say, hey, move this money out of this smart contract to me. They realized that another contract was actually technically given administrative rights, is the simplest way to put it, over that contract that had access to who, what, when, where, why with all the wallets. And they therefore noted there were some vulnerabilities in that secondary contract. So basically, contract A has access to the wallets. Contract B has access to contract A. And contract B can be called by anyone on any participating blockchain network. Still with me so far, Michael?
Yes.
Good.
I think so.
So
keep it rolling.
So
I think maybe you just call out that like this like structure where you have, functions in a contract.
Mm-hmm.
Some of those functions are kind of access protected.
Mm-hmm.
And there's like a kind of concept where one contract can like own another contract and call into kind of privileged functions within it. That's very common.
That is very common.
Very common
smart
structure
contract world.
in Solidity and in the kind of smart contract world.
Yeah,
like this
and it makes sense. That's not the vulnerability.
Yeah, like that's part of how these systems are built, which is I think worth some discussion points as well. But yeah.
Oh, okay. Let's dive into those.
Well, maybe
or did you mean a separate podcast?
Set a flagpole a little bit too early. No, I think I just mean it's interesting. Like from a security perspective, it's interesting that it's one of those things. Like we had an episode a while ago about like moving from Web 2 to Web 3. I think I don't even remember what episodes we had, but like what concepts in Web 2 carry over to Web 3 and what ones don't, or what ones get kind of morphed when you carry them over to Web 3. And I think access control is one of those concepts that takes a pretty big evolution or a pretty big like permutation.
Yes, it does.
When you move it from Web 2 to Web 3. And the idea that like, in a way, there's kind of a primary access control privative, which is like ability to call a function, which doesn't have a straight corollary in Web 2 necessarily. No. And it's because what you're saying, like the code is law stuff, like, code is public, it's all there, it's all kind of publicly available and callable and whatever. And so when you think about access control, it operates at like a different place in Web 3 than in Web 2, which makes these designs feel to me, they feel unintuitive. Like the designs feel a little bit unintuitive just because you're so used to Web.
Yeah, because you're so used to Web 2. And Web 2 kind of works analogous to physical security in some respects. You have a room, only certain people have access to code to that room. Whereas Web 3 turns that on its head. Everybody has, like you said, everyone has access. So how are we differentiating and how are we even implementing? Do we even have a right to implement access control to certain things? And you're like, well, you're going to have to, because you have high privileged functionality embedded within some of these contracts, and you only want certain people to be able to call them, or certain assets, or certain functions,
identities, or whatever, right?
Entities, to be able to call them. So then how do we go about that? Okay, we use public key cryptography. Okay, but then get back to a point we discuss many times throughout this podcast. you're just moving the security boundary. That's
It's a
what you're
different
doing here.
boundary. Yeah,
It's a
it's an
different
entirely
boundary.
different place of putting the boundary, and
Yeah.
it feels like I'm trying to think. It gives me a feel. You know what I mean?
Yes.
Like when I think about it, I feel a certain way about it,
Yeah,
which is a weird thing
definitely.
to say, but it feels much more like imminent.
Yeah.
Like it feels much more closer to, like, I want to say closer to the metal, but that's not quite the right word,
Hmm.
because
I know what
but
you're
like, you know what
saying.
I mean? Like it's
Yeah,
lower, like it feels lower level. It feels more
it is lower
imminent.
level.
It's less abstracted in a way. Um, but it also feels kind of harder in some ways.
Way harder.
Like,
I
yeah,
genuinely, I think, again, this is foreshadowing my conclusions. I think this is an interesting path to go down, again, for the sake of extreme decentralization maximalism, because it is now harder. You've now made your life more complicated. So contract A has access. Contract A has a bunch of highly privileged functions in it, including one of them, which is who has access to the wallets and who can move money in and out of these wallets. No one can call contract A apart from contract B, but everyone can call contract B. So now what you've done is you've moved your security boundary to contract B, and contract B has to be, as you said, it's harder. You have to be on your P's and Q's. It has to have been threat modeled to within an inch of its life, not just from a code level, but from an user abstraction level, which is kind of where one of the vulnerabilities was found. Because now basically what the attacker realized was they could actually they could insert their own parameters to contract A via contract B, because contract B had a vulnerability. So they were able to add themselves as effectively an administrator of one of the wallets via contract A. And the thing is, I can almost see what happened. Like, I know contract A was locked down to within an inch of its life. But then contract B, they were like, well, it's not so high risk. So I can imagine it, I don't know, maybe it got less oversight or whatever. It had less testing. I don't know. But
yeah, I don't know.
we'll never know. But at the same time, you still have this issue where you're only as secure as your weakest link. This is a classic case of that. And so basically, we haven't even finished, by the way. But anyway, so contract B can call functions in contract A. It can call highly privileged functions in contract A. And contract B didn't have the necessary checks and guards as it should have, checks and security as it should have, which allowed a malicious attacker to basically add themselves to that list that contract A controlled of people who controlled wallets. That's kind of, so now if you're doing your thinking and you're listening, you can see what happens here. Basically, they hacked contract A by adding them, well, they hacked the wallets by adding themselves as an administrator of these wallets via contract B on contract A, and then issued a transaction from an Ethereum network to transact and transfer, drained the Ethereum wallet that they had at the time, which at the time of when it happened, the amount of Ethereum in that wallet was equal to $610 million worth. That's, I'm just going to stop there, Michael. Is that your reading of how the attacks? I don't want to misquote anything.
Yeah,
Right?
I think so. I think there were a few different. I think there were multiple wallets involved.
Yes, there
Like, I
were
think there
multiple
was
wallets
on different blockchains. Like, I don't think it was just Ethereum. So I think the value
Yes.
was
Sorry. Yeah. My
in
mistake.
multiple wallets. I forgot what it
correct.
was. Ethereum. Was it Solana?
I'm checking notes.
Binance Coin, I think, was one.
Yeah, Binance was one. Matic is another one.
Okay. But yeah, I agree. Like, the chain being smart contract B, you could kind of publicly call into it, and it had a privileged ability to call functions in contract A.
Mm-hmm.
One of those functions allowed the caller to insert to modify the list of allowed, like basically the key holders. They called it keepers, I think.
They called
is,
it keepers,
is their term,
which was kind of
which I think is short for bookkeepers.
Oh, okay. Yeah,
but keepers actually sounds way more like sci-fi cool.
Yeah, it does.
Thing,
it does.
So.
It's almost science fantasy. It's
yeah,
like...
yeah. It sounds really cool. So I like that. But I think, like, there is an additional kind of wrinkle to this, right? Because it wasn't just the case that, like, oh, whoops, you can call a function in contract B and then that calls the function in contract A. Like, it wasn't quite that straightforward. There was an additional vulnerability necessary because, they did anticipate that, obviously, this contract B is public and people can call different functions in it. So they did anticipate that and design for that. But there was an additional vulnerability in the contract that meant you could do this, which is where kind of the nerd like interest is in this particular attack, I think.
Exactly. So, I'm going to let you start with this one. Okay, so we have to explain hashing here. Okay. No, you go on first.
Do we? We can.
No, I don't think we do. I think we can do it. We can abstract away from that. All right, you go ahead.
Well, no, we'll try. Okay, so basically, this is a tough one.
It is. It's not a joke.
There was a function in contract B that you could supply data to. You could call and supply data to. And that function, when it ran, it would call a function in contract A.
Yep.
Based on the hash of the data you supplied plus some other stuff in the function. Basically a method signature. Basically, like part of the data you supplied went into a method signature, and then it hashed it together to determine what function to call in contract A.
Yeah.
And this is a pattern in smart contracts, like identifying functions by the hash of their signature.
Yeah.
It's probably a word for that I don't have on my tongue right now. But
as in what they call it in the smart contract world.
Yeah.
Yeah, it's literally function signature.
Okay. Yeah. So that's a common pattern, right?
That is and if we should say that's a common pattern in Web3. In Web2, you just call your function whatever you want to call it.
Yes, it's a common pattern in Web3, and this is again a different thing. This is part of being in the different world, right? So part of why they did things this way, part of this was meant to, I think, control what functions could be called in the other contract.
Yeah.
What the attacker realized, what the threat realized was that, hey, I have the ability to control what input I give to this function.
Yeah.
So there's user input, there's untrusted input to this function.
And for those following, the attacker realized they have the ability to influence the input of what was given to contracts A function. So there's the function that contract B, they supply it to contract B's function, and then that gets passed on blindly from the looks of things to contract A's highly privileged function. That's what Michael's talking about there for those that are following. So they realize that.
And so if I, because the input that I give is going to get hashed together to get this function identifier, this hashed function identifier, that's going to identify what function gets called in contract B.
Yeah.
Maybe if I structure my input a certain way, I can get it to hash to the same signature as this highly privileged function that lets me add a key as a keeper.
Yeah.
So in security terms, this is called a hash collision.
Yeah.
When two different pieces of input hash to the same value.
Yeah.
Now, I don't know how much of the security stuff we want to explain, I guess, but hash collisions exist always because you're taking a larger piece of input and making it a smaller piece of output. So there's
fixed length.
Less space, fixed length. Yeah. So there's always hash inputs, always hash collisions. But the key thing about them, if you're using a hash as a kind of security control, like if the hashing process is part of your security design, the key thing about them is like how hard is it to find one of those collisions, right?
Yeah.
Ideally, it's very, very hard.
Yeah.
Because it's long, because that correlates pretty squarely to the length.
Yes.
In this case, though, the hash was short.
Yeah.
Basic, like TLDR, basically. The hash was short. I forget how many bytes. 32 bytes? Bits?
Sorry, let me just check. Yeah, so basically the hash was truncated to 32 bytes from 256-bit hash. So initially, when hash...
32 bits or bytes? I think it matters.
Oh, so of course that matters. I think it's 32 bits.
4 bytes, right?
It's 4 bytes, so it's 32 bits.
Yeah. Which is short for a hash.
It is very
I
short.
think like it depends a little bit on the hash function. I don't know this one specifically. It's like KEC. There's a way
Yeah,
people pronounce this,
I
I'm
said,
sure.
yeah,
KECCAK, whatever.
yeah.
But like a 32-bit like SHA-2 or whatever hash,
Mm-hmm.
you can find a collision for that. I don't know. I think in seconds
Yeah,
on a laptop.
on decent hardware, yeah, in seconds.
Yeah. So not difficult. You
Mm-hmm.
would normally try to design things so that takes, years to
Years and years and years.
millenniums
Yeah.
or whatever, right?
Mm-hmm.
So anyway, the threat found a collision.
Mm-hmm.
They could supply this particular string to this function,
Mm-hmm.
and it would hash in such a way that it collided with the function signature identifier of the privilege function that they wanted to call in contract A.
Pausing you. Yeah, there we
Yes.
go. Done. Yeah, just making you track. So the hash
Oh,
would happen in contract B to
Yes.
call the high privilege function.
Yeah,
in
you
contract A.
call the function in contract B with your input.
Yeah.
It hashes it. It collides with the function signature in contract A,
Mm-hmm.
and then it says, "Okay, I'm going to call that function."
Yeah.
And then it calls that function in A. It's able to do that because it's contract B calling
Mm-hmm.
it, which it's privileged to do.
Yeah.
And then if you supply it with your key as well as part
Yeah.
of the data or whatever, then you can get your key.
You can get your key added to the list of keepers, which effectively makes you wallet custodian, and then you transfer the money. Wow. Thoughts, Michael? Initially, my thoughts were I had so the security engineer immediately was zeroed in on the hashing. Why truncate the hash from 256 bits to 32 bits? Because obviously you then increase the possibility of collisions. So that's the technical thing. Then my next thought was, okay, we've got effectively security boundaries, like we said, delegated access rights. Why contract B? Yes, you did lock down contract A, but you need to make sure contract B, if it's passing vulnerabilities, well, it kind of did, passing parameters onto contract A from contract B, you need to make sure contract B is doing all the, what we would normally would say client side validation. That's muscle memory, just validation. I guess it is client side in a way. So yeah, you need to make sure it's validating whatever it's passing on to make sure that even if it can call the correct hash, should it be calling that hash? Under what circumstance would you need people? So this is where threat modeling comes in, where you go up the stack in terms of why, under what circumstance would that code need to be called anyway, and should we should really be designing security controls around that. Again, that's the threat modeler in me.
Mm-hmm.
And then so those were the two major things that immediately jumped out at me, like the first time I read over this. The aftermath, I'll let you go. Actually, what immediately jumped out to you?
Well, I think like kind of one like unanswered question I had was this the only, like, were there some constraints that made this the only or the best division of labor between these smart contracts? Maybe there were design constraints, or maybe there was some reason why, but like, would it have been possible to not have the overlap between some of these functions and the like privilege functions that had the owner permissions? Like, would this have benefited from an alternate contract structure?
Yeah,
I don't know. Maybe I didn't get far enough in like looking at that. Especially when, like, we say like these functions are access control boundaries, right?
Yeah.
My other thought is like using a hash as a security control, like as a security boundary, very difficult to do right.
Very.
Like, obviously there's use cases for it, and like, they're designed to be cryptographically secure and all this kind of stuff, right? But easy to mess up with them.
Very.
And in like a Web 2 world, there's a lot of times where if you find yourself thinking like, I should use a hash as this kind of security boundary, you're usually, I don't know, I think a lot of times you're better off separating the identifier completely from the underlying data and having like, a lookup table between them or whatever. And you trade off like compute time, like you trade off lookup time for just having that actual separation between the identifier and the thing. So yeah, that's another thing my brain thinks about, like this way that hashing is kind of enforcing a security boundary here. Like, does it make sense? Are there other options? Whatever, that kind of stuff.
Especially if you're going to undermine the efficacy of that security boundary. If you're going to come up with a 256-bit hash and then only use the first 82 bits, you're weakening the actual security boundary that you've got there. So
Yeah, and
that
then
is
it's like, but then it's like, like one of the reasons why it's tricky is because it's easy to become unaware that it is operating as a security boundary, right? Like it's easy to like,
and that's true.
when there's different people involved, when there's different entities involved,
Mhm.
it like kind of trust is placed in this area, but
Yeah.
then it maybe gets used in a different place where it's unknown that that trust was placed
I
in
think
it.
that's what you've triggered in me. I'm like, when they're coming up with function signatures in Ethereum, was it actually was it conceptualized as a security boundary, or was it just conceptualized as a robust identifier? Because you can have all these smart contracts with all these functions, they're bound to overlap in names. How about we just make it very, very easy to come up with unique identifiers? Like, that's part of the thing that jumps to mind. I think you're right. Was it ever conceived as a security boundary in the first place? Yeah.
Yeah, I think those are, and then obviously stuff we talked about like kind of function level access control and what that means and how you have
Mm.
to get your head, like getting your head into that game is
Mhm.
I think also kind of tricky.
I think it's
It's
tricky
not,
and
doesn't feel intuitive,
at all.
but it's hard to say whether that's just like familiarity or whether
Yeah,
that's
maybe.
yeah.
But also, if you make it, I mean, I think design and UX shows that if you make it easy to get wrong, lots and lots of people will get it wrong. And this is why I think we've discussed it maybe back in episode 1 or 2. Code is law is a very interesting philosophy to have, because if you want to expand accessibility, if you want a million developers to build on your platform, you need to make it very easy to get things right. You need to make it quite hard to get security wrong. That's, I mean, whether people like the sound of that or not. And if you're going to decentralize, then security becomes a much more important, it becomes first and foremost, right? Because now you've got this trustless network where people are supposed to be able to rely upon the network and the code itself. So now your code needs to be bulletproof all the time, which is, I mean, I'm not going to say impossible, but that's a steep mountain to climb. That's
Yeah.
a very hard objective to try and hit. And so then you peel the back, and it's like, you peel that back and you're like, okay, fine. We've decided code is law because we really want everything to be decentralized.
Yeah. And I think like something that kind of puts the brakes on things a little bit in a Web2 world, that like, okay, like the other thing that stands out about this and basically all the hacks that we've talked about, just the velocity, right? Like the velocity of the loss
Yeah.
is extreme.
It's $600 million.
Yeah. And how long does it take those transactions to execute? Like max the order of minutes, probably, right?
Minutes.
So that does not exist in the Web2 world. Like in the Web2 world, the velocity is 100 to 1,000x that,
Yeah.
or something.
Yeah.
Like you can't affect that much loss that quickly.
No.
And so that's something that's like really significantly different. I think it highlights your point about like having to be on it all the time, right?
Yeah.
Because there's way less margin for error, not just because things are public, not just because it's accessible and public and all of that kind of stuff, but also just because the velocity that these things happen at is extreme. Really.
It's extreme, and funnily enough, I think that extremity serves to undermine trust in the network. Ironic. I think it's not a paradox, but it's very strange. Obviously, you've got this trust in networks. We can all trust in what we see, but you don't know what you don't know, and there's always a vulnerability lurking somewhere. Which is why I mean, if we wanted to just do hacks for the rest of this podcast, we could be going ad infinitum, because there's always a vulnerability. That's kind of how it is in code. Nothing's perfect. So, and the problem is the velocity paired with the tokenization and the financialization inherent in these blockchain networks means a lot of money can go in very quickly. Now, this brings us on to the aftermath, which is quite interesting, because again, with the openness of these networks, one of the positives is everyone saw it happen, and the attacker was actually struggling to launder the funds out of any of the network. All the assets were traceable, long story short. And so they were able to see that move through the network, and these exchanges were able to block any transactions to be able to exit the network. So the attacker, ironically enough, ended up giving back all the money. Giving back all the money and then claiming it was actually a grey hat exercise, basically. So that's why they did it. Which is a very strange turn of events. And then it gets even stranger, because Poly Network then offered them a job as their chief security officer, and $500,000 as a bounty, both of which the attacker turned down. Understandable, because it was very clear, mate, that if you could get that money out, you were going to take that money, and as a result, they would have your details. And I'm pretty sure you'd end up in a jail cell if you said yes and gave them all your details. So, yeah, that was quite interesting. I'm not one of these proponents of. I mean, this used to happen a lot in security, in early days of security, of giving people jobs who found holes in your system, because it incentivizes not great behavior in some ways. There's a bunch of
I
also
think they're
there's
also different skill sets, like
right,
really.
exactly, very true.
Um, Especially when you talk about, executive level stuff or
Executive, yeah,
like
exactly.
management level stuff,
Management level.
it's a different
That's a
skill
very
set.
good point.
Yeah.
So that's what happened there. But now to go on to the point that I foreshadowed earlier, decentralizing. It's weird because again, we come from a Web 2 world, so immediately in my mind, where's the auditing, where the logging? You have the logging on the blockchain, everyone can see it happening. Auditing is actually looking at those logs and doing something about it in reaction. People did, volunteers did, so they caught it quickly. But then I'm like, is there any way we could have now? As you said, the velocity. Is there a way? Is there a method? Is there an idea we could have around being able to slow down the velocity of these attacks? Because that is one of the constant themes that we see throughout these attacks: is the velocity in which they happen and the size of which they happen. So it's like, okay, when you see
Yeah.
$500 million transactions in the same epoch or in the same blockchain cycle, should something trigger? But then you're talking about centralization, right?
Maybe, I don't know. Maybe you could come up with something. I think like the centralization, decentralization stuff,
Mm-hmm.
it is not. You have to think about what level you're talking about it from, right?
Mm-hmm.
Like a lot of people who really advocate the decentralization side of things are thinking of a certain kind of centralization that they don't want to have, right?
Yes, 1,000,000%.
A certain kind of like decision making over your ability to do something.
Yeah.
Like that's what they mean by centralization or something.
Mm-hmm.
And we kind of talked about, like, it's also over like the code that does something in a way. Like we talked
Mm-hmm.
about that a bit in our whatever episode where we talk
Mm-hmm.
about it might have been our first one.
Yeah. Why are we here?
But like I think there's another way to look at this, that like having 600 million amount, like having a pot of gold that big,
mm-hmm.
that's managed by a smart contract practically, is also a kind of centralization, right? Like you've really centralized trust in one place.
Yeah.
It's one place that is executed in a distributed way and is maybe even governed in a distributed way. But it is still in a meaningful way like one thing.
Yeah, it's one contract that has access
And
to.
yeah, and so I think like, yeah, a decent amount, it's interesting, right? Like a decent amount of the blockchain world and the Web3 world, in a lot of places there aren't very many players, and like a lot of air gets sucked into like the momentum, right? Like a lot of trust and a lot of value follows into the same places based on what's working and what offers certain functionality and whatever. And that is a kind of centralization. I think a meaningful kind of centralization when you're thinking about security on the blockchain. Yeah.
But basically, there is centralizations happening at different level of and decentralization. It's varying on a spectrum, and it's varying at different abstractions as well. And for me, I think a more grown-up conversation needs to be had around effectively the value of a middle person. Because what's happening here, what's driving these conversations when you and I come and study all of these different aspects of blockchains is, again, we talked about it a lot in our first episode, Why Are We Here? How much authority should an entity have over something that touches lots of people, lots of users, or is distributed? How much distribution of that authority is enough? And at the end of the day, I feel like going from one extreme saying there should be no middle person, there should be no centralized authority, to authority should be completely, and from there should be none of that, to actually it should be just one person who ultimately decides what happens on this network, or what happens with this infrastructure, what happens in this system. I think, again, on that spectrum, it depends on where you want to be. But I think with things like this, they swing over to one extreme and devalue and pretend like there is no value to having any type of centralization at any abstraction. And I think that's an extreme position to occupy, especially if you're doing something as complex as coding smart contracts that are
Yeah.
calling other smart contracts that are handling hundreds of millions of dollars. Like, a thought that just came to me while you were talking, sorry, I'll just let you
Yeah.
jump in now, is again, a trigger somewhere, an alert. Oh, Ethereum's price is rising ridiculously, so our wallet is now rising ridiculously. That should trigger someone to say something or do something around. Again, if you're, I don't know, do we need to put any extra security controls? Do we need to do extra logging and alerting somewhere across the network? Because we are now, our risk posture has changed from being a $250 million entity to $1 billion entity, just like that. Because basically people are now trading more, and an asset has gone up more. Your entire risk posture is different. And risk posture from a mom and pop store to a small to medium business enterprise that has 100 employees to 5x that, those all have different threat models, and those are all different. Therefore, they need different security controls, etc., etc. That can happen to these decentralized entities overnight. So I don't know. What do you think?
I think like to take the kind of to play the like decentralized kind of foil to that, right?
Mm,
I think the difficulty is it's hard to introduce meaningful and effective centralization points into these systems in a way that doesn't just collapse to it being centralized.
yeah, one
Like
hundred
it's
percent.
it's hard to have a stable kind, like it's not stable
Mm-hmm.
really, because you know you're going to want to put the centralization in the important points, and then it's kind of like, well, then what's the decentralized stuff
What's decent? Yeah.
doing, you know? So I think it's difficult. Like I definitely see what you're saying, and I think your point about when you look at these ecosystems as a whole,
Mm-hmm.
at every layer and in every player, there's a spectrum of centralization and decentralization based on how
Mm-hmm.
much trust is actually distributed to how many players,
Yeah.
right? Um, and it's not straightforward that we can just say it's decentralized, right?
Yeah.
Um, so like in a way, that's the on the ground truth.
Mm-hmm.
But yeah, I think like meaningful centralization at important points is difficult to have it not collapse back to being to being like a truly centralized
True
system, I
centralized
guess,
system.
which I think is the difficulty, and I think
Mm-hmm.
is why people can be kind of uh um like kind of extreme about it,
Mm-hmm.
right?
Because
um
they know that temptation is there. Once you put it in, it's more than likely going to happen.
yeah, and the interesting point is like, why did this attack stop? Well, it was the centralization points where you try to get money out, right? Like the places where it touches on the
Mm-hmm.
um the traditional financial system, like
Yeah.
the exchange points there were where you were able to pull a lever and put a
Yeah,
brake on
exactly. That's a
something
very good
happening,
point. Yeah.
um which is something for people to think about.
It is
I don't
something
know
to,
what
because
conclusion you can draw, different conclusions from that, but yeah, it is kind of funny that
I know what conclusion that tells me. It tells me, like we said in the first episode, both systems are going to coexist.
yeah,
There's no
yeah,
one's not replacing the other.
yeah.
They are both going to coexist ad infinitum. Thank you for listening. Apologies again for our delay. It's the Christmas season, and both Michael and I are busy family men, so there may be some sporadic postings, but we will keep going, and we will find another cool topic. Otherwise, if you made it through to the end, thank you, and as always, we appreciate your support. And goodbye.